Okay, good day everyone. So today we'll be having a discussion in power plant steam. So it's more on about troubleshooting. So before we start with troubleshooting, so let's talk first about how long does a boiler service take. Okay, so what do we usually you normally do on our boilers? Okay, so what is a boiler service? A boiler service is a comprehensive inspection and maintenance procedure performed on your boiler to ensure it operates efficiently and safely. So during a boiler service, a qualified engineer examines all the key components of your boiler, including the heat exchanger, burner, main injector, and spark probe. So the engineer will also check for any leaks, corrosion, or wear and tear that could affect the boiler's performance. So regular boiler service Sing helps to identify and resolve minor issues before they turn into major problems. So usually when we do duty rounds, so we are also checking if everything is okay on our equipment. So that's also a part of the boiler service. Okay, so what happens during a boiler service? During a boiler service, the engineer will follow a systematic checklist, which generally includes the following steps. Visual inspection. So you will have to check whether there is unusual on all the uh, um, all your equipments visually. We have internal inspection, we have flue and combustion check, we have electrical components check, we have pressure and seals check, and cleaning and operational check. So these are the usual boiler service that or checkings that we have to do every day. So what happens during a boiler service? So for visual inspection, the engineer will start with a visual check of the boiler and its surroundings. So this includes inspecting the boiler's casing, pipework, and flue to ensure there are no signs of leaks, corrosions, or blockages. So the boiler's installation and position will also be reviewed to ensure it complies with current safety regulations. So for internal inspection, we have the engineer will remove the boiler casing to examine the internal components. So we don't do this every day. We do have scheduled maintenance for this one. So this includes checking the heat exchanger, burner, main injector, and spark probe for any signs of wear, damage, or blockages. So the condition and cleanliness of these components are crucial for efficient operation. Next, for flue and combustion check, the flue is inspected to ensure it is clear of obstructions and properly connected. The engineer will also check the boiler's combustion chamber using a flue gas analyzer to measure the levels of carbon monoxide and other toxic gases. So we have here a sample of a gas analyzer. So in here we can see that there are measurements, ppm of carbon monoxide, percentage of oxygen. We have here, that's efficiency, exhaust air percentage. We have CO2, carbon dioxide. So in here we can measure if the combustion is good or not. So this ensures the boiler is burning fuel safely and efficiently. Okay, next we have the electrical components check. So inside this control panel, we have so many components, electrical components that we have to check. Usually, we check the loosed wirings. We check if the contactors are moving, or you also test the emergency stop if it's working. So the engineer will inspect and test the electrical connections and controls, including the thermostat, wiring, and safety devices. So ensuring these components are functioning correctly is essential for the boiler's safe operation, especially the emergency stop. You should test if it's working. Next, for pressure and seals check, the system's pressure is checked and adjusted if necessary. We have pressure gauges all over our boiler, so we can adjust depending on the recommendations on our manufacturer. The engineer will also inspect seals and joints for signs of leaks or deterioration. So before a leakage or damage will occur, so you will have a replacement already. Next is for cleaning. So we have scheduled maintenance for this one, but also if you suspect that there is a blocked or dirty component, so you also have the choice to not wait for the next scheduled maintenance. So key components such as the heat exchanger and burner are cleaned if necessary to remove any buildup of dirt or debris which can affect the boiler's efficiency and performance. So next, operational check. Finally, the boiler is reassembled and the engineer will fire it up to check its operation. So this includes verifying that it starts correctly, runs smoothly, and all controls are functioning as expected. All the temperature, pressure are okay. After completing these steps, the engineer will provide a service report outlining any findings, work carried out, and any recommendations for further maintenance or repairs of the said equipment. Okay, so that's how we do our boiler service. So that's how we check, that's how we ensure that the boiler will run and is running smoothly while operating. Okay, next. So special occasions will occur also that even though we do our boiler service, there will be problems or there will be problems in our equipments or in our boiler. So we should also have to apply the analysis in fault detection and initiate actions to be taken during operations to meet consistently the requirements. Okay, so these are examples of different shutdowns and alarms for our boiler. So there are so many alarms for boiler only. So these alarms are for boiler only. And in our engine room, we have so many equipments running. So every equipment has their own alarm also. Okay, so these are sample boiler shutdown, boiler alarms. Yeah, that one. So there are more than 100 alarms that may be activated during our boiler operation. So these alarms ensures that the personnel will be notified before a damage, or will be notified that there is a problem in the boiler. So that is the alarm. And then we have also shutdown. So those shutdown, activation of shutdown is used to protect the boiler from being damaged or the personnel from being damaged by the accident, or to prevent pollution. So we have also shutdown activation of our equipment. Okay, so we will go now to troubleshooting. So in the picture below, this is a type of boiler in which, this is an old type of boiler in which you will have to put a fire inside before it will create its burning. So we have a practice here for maybe this is a messman practice trying to fire a boiler. Because of its uniform, it looks like a messman. Or maybe this is in their company, this uniform is for oilers maybe, or I'm not sure. Okay, so let's talk about safety and emergency procedure for low pressure and high pressure boiler. So if ever pag ganito na yung boiler, iwan pa ba? Parang hindi na, di ba? Okay, so let's go. So when must a boiler be stopped immediately? So think, when must a boiler be stopped immediately? So there are different scenarios or occasions that you should stop the boiler immediately. Okay, so when you have to stop a boiler, you have to activate the emergency stop push button. So the boiler must be taken out of service immediately if a substantial loss of water is noted. So pag naubos na yung tubig, you should have to stop the boiler, or pag mababa na yung tubig. Next, the safety valve cannot function if the safety valve of the boiler, which protects the boiler from overpressure and protects the boiler from damage. So if that safety valve is not functioning, you should stop the boiler immediately. Next, if the oil in the boiler water is detected. If there is oil in the boiler water, so you should stop the boiler, remove the oil, and inspect where that oil came from. Next, too high salinity level is detected. If there is too much chloride or salinity in our water, you should stop it immediately to prevent scaling from building up inside the boiler, and then rectify the problem first before starting it again. Okay, so marine boilers are critical components of a ship's machinery, providing steam for propulsion, heating, and various other functions. So proper handling and maintenance are essential to ensure their safe operation. Below are the safety and emergency procedures for various scenarios. Okay, first, for a substantial loss of water is noted. So symptoms, a significant drop in boiler water, you can see it in our sight glass. Then low water alarm is activated. So there will be an alarm. Potential boiler feed pump failure. So these are the symptoms that there will be a substantial loss of water in your boiler. So procedures, immediate actions. So shut down the burner or shut down the boiler. Immediately shut down the boiler burner to prevent overheating and possible damage. Isolate the boiler. Close the steam stop valve to isolate the boiler from the steam system. Check the feed water system. Inspect the feed water pumps, valves, and pipings for any blockages or leaks. Restore water level. So if everything is now okay, attempt to restore the water level by using the standby feed water pump or another available source. Then, for inspection and repair, investigate the cause, determine the cause of the water loss, such as a pump failure, check the pump. Valve malfunction, maybe the valve is closed or not opening, that's why there is no flow. Or leakage, so you should check the tubes if there are leakage in the tubes or in the pipes, and then repair as needed. Perform necessary repairs to the feed water system or any leaking components. Next, if everything is now okay, you can now restart your boiler. So gradual reheating. If the boiler is cooled, reheat it gradually to avoid thermal stress. And closely monitor the water level and other parameters during the restart process. If everything's okay, then you're good now. Okay. Okay, next. Safety valve not working. What will you do? Okay, what will you do if your safety valve is not working? Okay, so symptoms, inability to relieve excess pressure. The potential overpressure alarm activation is activated. So overpressure alarm activated, and hopefully the boiler will shut down from overpressure. But if it doesn't shut down, then there will be a problem, especially if the safety valve is not working. So immediate action, shut down the burner, shut down the boiler burner to prevent further pressure buildup. Then manually release the steam pressure. So use any available manual pressure relief valves or vents to reduce boiler pressure safely. Isolate the boiler. Close the steam stop valve to isolate the boiler from the steam system. Next, inspection and repair. Inspect the safety valve. Check the safety valve for any obstructions, mechanical failures, or incorrect settings. So usually we have two safety valves. So you can you have to check the one that is not working and replace it if possible, so that two safety valve will be working when you restart the boiler. Replace if necessary. So the safety valve, if it is found to be defective or beyond repair, replace it immediately, or you rectify the problem. Next, if everything is now okay, you put back the working safety valve. You can now restart your boiler. Test the safety valve. Ensure the new or repaired safety valve functions correctly before starting the boiler. Then, monitor the boiler pressure closely during the restart process to ensure safe operation. And try to activate the safety valve at the right setting. Okay, so if the setting will be, for example, it activates at around 8.5 bar, so be sure that at 8.5 bar it will open. So there is sight glass. If you can see that if there is flow in the safety valve outlet, and then adjust if the steam pressure is not correct on the setting, so adjust. Okay, next, what will you do if oil in the boiler water is detected? So pag ganito pa naman kadumi, hindi mo na yan lilinisan siguro. Joke. Okay, so what will you do if oil in the boiler water is detected? So gaganin, kakapain mo ba pag may oil? Okay, so causes of oil contamination in the boiler. So we have fuel system leaks. Leaks from fuel lines, fuel pumps, or other components of the fuel oil system can lead to oil entering the boiler water. So this can happen during fuel delivery, pumping, or through worn seals or gaskets. Contaminated feed water. So feed water that is supplied to the boiler may become contaminated with oil, either from a leak in the feed water system or if the water source itself is polluted by oil from external sources like spills or runoff. Or maybe your feed water in your consumers, there is leakage in there, so there will be some contaminated feed water also. Improper maintenance and cleaning. During maintenance, improper handling or cleaning of equipment, especially when working with fuel oil systems, can result in oil contamination. So for example, cleaning tools or equipment with oil could introduce residual oil into the boiler system. Next is we have the malfunctioning oil to water heat exchanger. So if the oil water heat exchanger, which transfers heat between oil and water system, malfunctions, oil could leak into the water side of the boiler. This is a common cause of oil contamination in the feed water. So effects of oil contamination in the boiler. So we have reduced heat transfer efficiency. So since oil is a poor conductor of heat, this can cause overheating, which can lead to metal fatigue or failure of the boiler. Next, overheating and tube failure. So it can weaken the metal, causing the tubes to warp or even rupture and lead to explosions or fires in extreme cases. So this is a warping of the metal. Foaming and priming, so leading to issues including turbine blade erosion and scaling. So your turbine blades will be damaged if there will be foaming and priming. Other effects of oil contamination: reduced water quality and potential carryover, can foul and damage superheaters, turbines, and heat exchangers. And increased maintenance and cleaning costs, can be labor intensive, costly, and might require a boiler shutdown, affecting operational schedules. So in this video, in this picture, we can see dry ice blasting is a faster and more effective way of cleaning turbine blades and shaft, completely removing oxidation. So dry ice blasting. So this, you will have to do this if there will be a contamination of oil in your turbine. Okay, another effect of oil contamination is the risk of explosion or fire. So oil contamination where temperatures are high increases the risk of fire and explosions. So safety and emergency procedure for oil in the boiler water is detected. So oil in the boiler water is detected. Symptoms. So presence of oil in the boiler water gauge glass. So this is a gauge glass. If there is oil in your gauge glass, then should be there is oil in your water. Oily water discharge from the blowdown valves. Reduced heat transfer efficiency. Okay, those are the symptoms. Okay, so procedures, what will we do? Immediate action. So shut down the burner, shut down the boiler burner to prevent further oil contamination. Isolate the boiler. Close the steam stop valve to isolate the boiler from the steam supply system. And stop the oil supply. Identify and stop the source of oil contamination, such as the leaking heat exchanger or fuel system. So what will we do next? After the immediate action, we have to clean and repair. So drain and clean the boiler, drain the contaminated water, and clean the boiler internally to remove any oil residues. So inspect and repair any faulty equipment such as heat exchanger, fuel lines, or seals. And thoroughly flush the feed water system to remove any residual oil. So after that, we can now restart procedure. Refill with clean water, refill the boiler with clean, treated water, and monitor the boiler water closely for any signs of residual oil contamination during the restart. Okay, next, we have too high salinity. What will you do? So pag ganyan pa naman yung asin, ano bang gagawin mo, di ba? Okay, so let's go. So symptoms of too high salinity level in our boiler water. So first, we have high salinity readings from boiler water tests. So we will have to take a sample and test the water sample of the boiler if the salinity is high or it's normal. So potential foaming or carryover in the steam. So if the salinity is very high, then there is potential foaming or carryover in the steam that will also prevent or lessen the heat transfer from steam to the consumers. So what are the immediate actions? blow down the boiler, perform a controlled blowdown to reduce the salinity level in the boiler water. So that's the only way. Blow down the boiler. If it's very high still after blowdown, then you may have to replace the water. So shut down the burner if necessary. If the salinity level remains high, shut down the boiler burner to prevent damage. So next is inspection and correction. Check for feed water quality. Inspect the feed water system for sources of high salinity such as seawater contamination or inadequate water treatment, or maybe your source has already high seawater or salinity. So inspect. So inspect desalination units. If applicable, check the operation of any onboard desalination or water purification system. Maybe your freshwater generator has so much scale that or there is a problem in the vacuum. That's why there is very high salinity in our water. So check it and rectify the problem. Then after that, if everything is now okay, restart procedure. Refill with low salinity water. Refill the boiler with treated low salinity water. Continue to monitor the salinity levels closely after restarting the boiler to ensure the problem is resolved. And then, if the problem is resolved, your face will be like this. So confident. Okay, so general safety considerations. Always follow the manufacturer's instructions and boiler-specific procedures for both normal operations and emergencies. So we have a manual on board, so always read it, always follow it. Next, regularly inspect and test safety devices like low water level alarms, control systems, safety valves, emergency shut-off valves to ensure they are working in condition. Also, the electrical emergency shutdown. It's regular inspect and test these devices because these are the devices that will protect us, protect the equipment, protect us, and protect the environment from possible damage. Next, training. Ensure that crew members are properly trained to handle emergencies, including water level management and controller troubleshooting. So we as engineers, we should always teach our cadets and our ratings how we do things, properly train them so that during emergencies they can help us. They can help us and control the problem and rectify the problem and prevent any more damages. Another safety consideration, always follow your vessel's SOP, standard operating procedures, for handling critical boiler alarms and failures. And then always, if in doubt, always call chief engineer. Okay, both low water level and controller failure are serious situations that can escalate quickly. So it is crucial to act swiftly, carefully, and according to the established emergency protocols to prevent significant damage to the boiler or risks to the safety of the crew and vessel and the environment also. Okay, so that's how general safety consideration. Okay, so now we will go to another one. So what will we do if this low water level and controller failure, there is a failure in our low water level alarm and our controller? So what will we do? Okay, so what is a low water level is a condition in a marine boiler. It is one of the most serious alarms indicating that the water level is critically low. So we have already explained this on our previous slide. So what will we do if there will be a low water level in our boiler? Okay, so we will skip this one. We will go to the failure in. Okay, we will go to emergency. Oh no, we're done with this. So we'll just review. Okay, emergency procedure for low water level. Immediate alarm response. Acknowledge the alarm. Shut down. Acknowledge the alarm and confirm that it is being monitored. Shut down burners immediately. Stop the feed pump if necessary. Check the water level. Inspect the sight glass and water level indicators. Confirm the actual water level in the boiler. So sometimes the level may appear low due to instrument malfunction rather than a real low water condition. And then open the emergency water feed valve if there is any. Manually open the feed water valve. Check for leaks. Check the feed water system. Assess the cause of low water level. So maybe it is a faulty feed water control valve, feed pump failure, loss of pressure in the boiler, a faulty level sensor. Check the automatic level control system. And then if everything is now okay, restored to normal operation, once the water level has been restored to a safe point, gradually restart the burner and bring the boiler back online. Test the system, monitor the system. Okay, and then record and report your findings in your boiler log. Log the incident, the boiler operation record, and report the event to the chief engineer and other relevant personnel for further investigation and review. So if the problem persists or if the low water condition reoccurs, a more thorough inspection of the boiler system will be necessary. Okay, next, what will we do if we have emergency procedure for, we have controller failure in our boiler? So this is on the electrical side. So emergency procedure for boiler control failure. So controller failures such as malfunctions of the PLC or automated water level control systems can severely disrupt normal boiler operation. Controller failure might affect the water level, burner operation, or safety interlocks. So this is what's inside our control panel. So first, if you have a controller failure, acknowledge the controller alarm. Acknowledge the alarm. So as soon as the control failure alarm is triggered, acknowledge the alarm to prevent further action from being delayed. Check the system's diagnostic display if available to determine the exact nature of the failure. Look for any fault codes or warnings. Okay, switch the system to manual mode. So in most modern marine boilers, there is an option to switch from automatic control to manual control. This will allow operators to maintain safe operation while troubleshooting the failure. So if the water level is at risk, manually adjust the feed water valve to maintain a safe water level and prevent the boiler from running dry. So usually we have emergency operation. You just have to follow it. Emergency operation procedures. Next, verify and isolate the faulty controller. So isolate the faulty controller. So if the controller is malfunctioning, disconnect it or power it down. For example, a malfunctioning PLC may need to be isolated to avoid incorrect instructions being sent to the boiler system. Identify the failed components, if like sensor, relay, controller module, by conducting a visual check and system diagnostic. Usually, if the PLC will be a problem, and we don't have a programming in onboard ship, so we will have to wait for technicians to do it. But if the problem will be sensors, relays, controller module, we can do something about it. Maybe we have spare parts, or we can rectify the problem. And then activate redundant or backup system if there is. If you have a backup system, switch to backup controls or secondary system that can temporarily take over the control functions of the faulty system. So activate emergency manual controls for critical functions such as burner operation, feed water control, and safety monitoring. Check the boiler's water level and burner operation. Manually adjust the water level, adjust the feed water flow, and check the burner. So manually adjust the burner's fire rate if necessary. Number 6, troubleshoot the controller. Find the problem. Inspect the controller hardware for faults such as loose wiring, blown fuses, or failed components. Or maybe the breaker has activated. So check for software errors if the controller is programmable, and restart the system if necessary. If you can do the restart, you try it. If the controller is part of a more complex system, ensure that communication lines between the boiler and control room are functioning properly. After that, notify senior engineering staff, notify the engineer on watch, notify the engineer who is doing the maintenance on these equipment, and report the failure to the chief engineer and other relevant personnel on board. So the controller failure may require immediate attention from the shore-based technical support team or the manufacturer for diagnosis and troubleshooting. So if there will be a communication, the chief engineer will go to the captain so that they will have to report this problem to the company so that the company can message or can look for a technician that can rectify this problem. And then monitor the boiler closely if you are starting it in manual, or if the controller is now operational, still monitor the boiler closely. Once the system is brought back online, monitor the boiler operation closely, paying attention to the water level, pressure, and burner operation. So if necessary, adjust the settings on the controller manually to ensure stable operation. And then record and report the problem, log the controller failure and the actions taken to resolve the issue in the vessel's maintenance and operation logbooks. So if repairs or parts replacements are required, arrange for the appropriate service as soon as possible. And then, if ever, if you have small spare parts, so order another set of spare parts for the as your stock, as your spare. That's it. So that's what will you do if there will be boiler controller failure. Oh, so many. Okay, so these are the different shutdown alarms. So we will discuss this on our next video.